so a parabola. Before we kind of defined a parabola like just as like the graph of a quadratic. Like I said, we're wanting to kind of get away from like functions. So remember that the graph of a parabola, kind of like our U-ish shape. And so the nice thing about a parabola is that it's symmetric, okay? And that's kind of what bases our definition on. So a parabola is the set of all points that are equal distance from a point, which we are going to call the focus, and a line, which is the directrix. So when we're looking at our parabola like we had before, basically what it's saying is there is an imaginary point somewhere here in the middle, which is called our focus, as well as an imaginary line, and the distance, which I didn't draw it very well, but the distance that it takes to get from any point to your focus and that same point to the directrix, those two values have to be the same. And that's going to be the case no matter what point of the parabola you're looking at. Now, like I said, the only difference is now we are also going to look at sideways or horizontal parabolas as well. So they also have a focus and a directrix. Quite a bit of like formulas and equations. Now this entire unit is very formula heavy, so what we're going to do is you're going to have a note card for your test over this. Like our main goal is just, do you understand what the different conic sections are and how to like find their equations and graph them, okay? We don't want you to get hung up on the like equation side of it. So you will be able to write down all the equations on a formula graph. Does that make sense? So don't freak out because there's a lot of equations and formulas on the next few pages. We know that. So we try and help a little. Alright. So this is our two. We have two standard form equations. So the first, okay, is kind of, it is similar to the one that we are used to looking at. It is where our x is being squared. We have x minus h quantity squared. However, it is slightly different because if we recall, our k was on the same side as our stuff that was being squared. When we're talking about conic sections, we do move everything else to the other side. So it tells us that it has a vertical axis, so that just means that your parabola is going to be vertical versus on my second one, we have y minus k squared. We have a horizontal axis, which means that my parabola is horizontal. second part is just, it is like at 0, 0, but really like as long as you know this one, the first two, then you just put in 0 for H and K. The other big thing is that our focus and our directrix are both going to be P units away. So the little two purple lines that I drew, those are both P units away. So let's look at some more. So, the biggest thing with either one of these is that your vertex for both of these is at H, comma, K. And like I said, our directrix and our focus are both P units away from our vertex, or any point on your parabola, but we usually just end up caring about the vertex. Okay? They're just opposite directions. So, to find our focus, we're going to say H, and we're going to add P to our K value. Or, if it's left and right, we're going to take H and add our P value. So like this second one is if it's horizontal. Now our directrix, again, is still just P units away. But it's in the opposite direction, so now we subtract instead. So we either have y equals k minus p if it's up and down, or x equals h minus p if it's left and right. And then the last thing to notice is that you're going to go up if P is positive, and down if P is negative. We will go right if P is positive, and left if P is negative. Alright, so let's look at how we use all of those fun formulas. Alright, so it says find the standard equation of a parabola with a vertex at the origin and a focus at 2, 0. So usually first it's going to be helpful to draw a picture, because that's going to tell us are we up and down or left and right. So where is the vertex for this parabola? At the origin. the focus for this, which is on the x-axis. And remember, for all of our pictures, our focus is like inside of the parabola. So if I know where the focus is, we know that our parabola has to open to the right this time, because the focus has to be inside the parabola. So if it's opening left and right, we know that we're using that y minus k quantity squared equals 4p times x minus h. And what are h and k? How do we find h? The vertex. So in this case, our vertex is at what? So what does that mean that h and k are? Are both 0. So we just get y squared equals 4p times x squared. And remind me, how do we find p? So p is the distance from what to what? That actually means the directrix to the vertex, or the vertex to the focus. So like the vertex is going to be right in between your directrix and your focus, which is why technically to go from the focus to the directrix would be 2.
So it's like the red dot, but is that the
Focus.
Okay.
Yes. No, it shouldn't be square. Sorry. It should be x. Thank you. So what does that mean that our p value is? 2, right? Because to go from 0, 0 to 2, 0, it's 2 units away. So we end up with y squared equals 8x. Because 4 times 2 gives us 8. And that would be our fraction. Good? Simplify. What do you mean simplify it? We don't want to. Like I said, with our conic sections, we're going to have lots of things that have x squared and y squared. And so we kind of just have to get over, like, there's going to be y squared. So. Other questions? Let's leave it alone. So it says find the focus of the parabola. So, what are the two things that we would need to know in order to be able to find the focus? So vertex and
What is that again?
the vertex is the one. So we need our vertex and we need the p-value, right? Those are the two things we would need, which we can get from our formula if our formula is in standard form. Is that formula in standard form? Does it look like the equations that we had at the beginning? Nope. So, what's wrong with it right now? It's in quadratic form, yes. We want to put it in standard form. So, what's wrong with it right now? Yeah. What else do we have going on there? Y is not squared, that's okay. This means we're going to have an up and down parabola. What do we else have there that's causing problems? Well, the x squared is okay. There are two x's. So we have an x squared and we have an x. Yes? And we just want it to be like x plus 1 squared or x minus 2 squared, right? We just want it to be like x and a number and all of that to be squared. Yes? Which remember, if I have x minus, or plus some number. We call that a perfect square. Yes. And in order to go for something from something that's not a perfect square to a perfect square, we have to complete the square. Do we remember completing the square? Do we remember at least doing completing the square? Yeah, you looked at it in both algebra 2 and the beginning of the square. So remember, basically, we're trying to think, okay, right now, that does not factor to give us a perfect square. So we want to add something into here, so some number, that makes it to where when I do factor it, I get a perfect square. And the formula that we end up using is b divided by 2 quantity squared. However, we can only start completing the square when our leading coefficient of x squared is 1. Right now, what is our leading coefficient of x squared? So what would I do in order to get rid of a negative 1/2 right there? I don't want to factor it out this time. I would probably multiply by what? Negative 2. So we end up with negative 2y equals, this just becomes x squared plus 2x minus 1. And when we're completing the square, we only care about the portion that has the x's. So that's the part that we're going to add the b divided by 2 squared into. So what is my b value? 2. So 2 divided by 2 is 1. 1 squared is also 1. Okay? So that's what we're going to add to the inside. However, in order to keep our equation balanced, what do we also have to do?
Do 2 this time?
I could. What else could we do instead? Yeah. So just say minus 1 on the outside as well. Because adding 1 to the other side is the same thing as subtracting it from the same side. So either way, we end up with the same thing. Now, what does that parentheses factor to now? Or in other words, what multiplies together to give you 1, adds together to give us 2? 1. 1 and 1, right? So we end up with x plus 1 quantity squared, which is what we wanted. We wanted a perfect square. Just x in a number with a square on the outside. However, right now we do have just a number hanging out on the outside. So minus 2. We do, because remember this time our x plus 1 squared needs to be all by itself. Yes? And then the other thing is we don't want there to be a number in front of y. Okay, so we're gonna, our last step is to factor out that negative 2. We end up with negative 2 times y minus 1 equals x plus 1 plus squared. So what do we say the two things that we need to know in order to find our focus are? Vertex and p-value. Well, now we can find those. What's our vertex going to be? No. Nope. Almost. Negative 1, comma, 1. Remember, it's the opposite side of your parentheses. Okay, and then how do we find our p-value? So in our equation, what was in front of the y? Yes. In the general equation, what's in front of the y? 4p. So we know that negative 2 equals 4p. So what does p equal? Negative what half? So then what do we do to find the focus? Well, we know that our p-value is the distance from the vertex to the focus. Yes? Oh, we do. If our x is what's being squared, and our p-value is negative, we know that this is at negative 1, 1, that it has to be pointing down. So which part of our vertex, so looking at our equations that we wrote out, do I want to add my p-value to x, to the h value, or do I want to add it to the y value, k? Yeah, so we would have negative 1, comma, 1 plus, I'm technically adding a negative, because my p-value is negative, so what do we get? And that would be our focus. Which is our final. Well, they asked us to find. Questions on that?
Where did you get the plus one and the one?
Where did I get what?
Plus one and the one.
The plus 1.
On the second line.
On my second step?
Yeah.
So remember that we take b divided by 2 and squared. So my b is 2, because it's x squared plus 2x. So 2 is our b value. So 2 divided by 2 is 1. 1 squared gives us what?
One.
So that's what we have to add to the inside of our parentheses. So that's where that first plus 1 came from. But then I can't just add a plus 1 because we feel like it. We have to keep our equation balanced, which is why we also subtracted a 1 from the outside. Other questions? Now let's graph it. See. One more. I'll bet equation. So find the standard form of equation of a parabola with vertex 2, 1 and focus 2, 4. What quadrant is our vertex in?
Second? I forgot which order it goes.
First one, 1. And then our focus is at 2, 4, so is that left, right, up, or down from our vertex? Which also means that our parabola has to open up. So that tells us that we use our x minus h. Quantity squared equals 4p times y minus k. So what's our h value? What's our k value? One. What's our p value? Or in other words, how far away is our vertex to our focus? 3. So we should plug that in. So 4 times 3 gives us and that's okay. So like I said, it's basically just using your different formulas to put it all into one. So now we should be graphing it. There we go. Now, this was our quadrant. aesthetic form. However, this is not our like standard conic section form. What do we need to do in order to put it into standard form? No, my square's already been completed. However, we need like my stuff that is a perfect square to be by itself.
So.
Okay. And then what to the -3? Which is the safety, guys? Yep. So then we should be able to find our different parts. So where is our vertex? If I wanted to find our focus, what do we have to find? Okay, so which equation are we using to find P? Or which number up there is going to give me P? Yes, but does -1/3 equal P? It equals 4P, so we would have to divide both sides by 4. So what is -1/3 divided by 4? -0.3. Yeah, that's fine. Are you okay with that? Are we found that? We're just setting that front number equal to 4P. So since my x is what's being squared and our p is negative, which way are we facing this time? It is vertical, but specifically if p is negative, it has to go down. Okay. But remind me, which one do I want to add p to? The 4 or the 5? The 5, because we're vertical this time. So what is 5 plus -0.083? No.
Oh.
That would be if you were subtracting. We're adding it, but it's negative. Alright. Now, for our directrix, we are going to be subtracting it, which means we end up adding it. So we do get 5.083 on that one. And remember that it's y equals whenever it's a vertical. So I'm going to go and plot some points. I have 4, 5. Our focus is at 4 and basically almost there. And then our directrix is right above. Now, because our p value is so small, that means that our parabola has been stretched. So it's going to be like skinnier than like normal. If your p value was large, then it would be bigger or like wider than normal. And that's right. Questions on that? It's going to be similar if we open left and right. It's just your focus is going to end up being either to the left or to the right. And then that's where you would draw your opening for your parabola.